Everybody, the title will become clear as I move through the presentation, because you probably won't believe what I'm going to say, but I'm going to do it anyway. I won't tell you all about Corus and Tata. I presume you know who we are and what we do. But our part, Corus, makes a very large amount of painted steels, most of which ends up in construction. Just to give you some simple numbers, we make about 1 million tonnes a year. That's about 100 million square metres of material that ends up as the external skin of buildings. Now, if anybody's going to take an interest in renewables and microgeneration on a macro scale, then it should be us, because we have the supply chain and the way of getting to market a very large volume of products very, very quickly. Now, we're working on PV, which you'd expect us to do. There's a poster reception down there all about PV. But if our vision is to move from making things that keep the rain out, and that's for 20, 30 or 40 years, to things that actually make energy, then you've got to start somewhere. So the place we decided to start is with an existing technology which was invented in Canada around about 20 years ago, called a Transpired solar collector. I'm not going to believe the way this works. There's a picture on the screen of what would appear to you to be a pre-coated steel sheet. The only difference between it and what you're used to is that it's got some small holes in it. And I'm hoping you can see the small holes. It's got about 5,000, it's about 1,000 perforations per square metre. And to date, and you won't believe this, as far as we can work out, on a bang-per-buck basis, it's the most attractive renewable energy yet invented. So I'll just go through that for you. It's a system which normally fits onto the wall of your building. It generates heat, not electricity. So we do need heat, and we do need a lot of heat if we're going to meet our targets, as I've explained earlier. Works best in cold, clear conditions. It just takes the sun's energy and converts it into heat. You can use to heat your building. Very importantly, you can put it on new builds, and that's where most of our material ends up. But it's so simple, you can put it onto existing buildings as well, and pretty much any type of existing building. I've said it's 50% efficient at converting solar energy into usable heating energy. That's a lie. It's more than that, but you wouldn't believe the real number. It isn't just a black, dark coloured product. We can make it in a large range of colours. And if you think of a large shed, and these are the sorts of buildings that we supply material to, a decent sized wall, 1,000 square metres, can make about 0.5 megawatt. And that's worth having. And if any of you want to do the sums, the average number over a year is about 250 kilowatt hours per square metre. That's not a peak, that's a degree day correlated average figure. And it pays for itself on a new build in 2 years, and on an existing building in up to 8 years. That sounds great, yeah? How does it work? Well, this is your steel shed, and as you can see on the left-hand side, we've got a box. This is greatly exaggerated. The sun shines on the painted steel, it gets warm, and it heats a very thin layer of air next to the steel. We use a fan, and we draw that thin boundary layer of air into the building. And it's as simple as that. That is then distributed either through high-level ducting, or in its most efficient way of using it, you feed it into an existing air handling unit. So the fan power then becomes free. It's not a passive system, it is active. It does need the fan to work, but the fan power is less than 5% of the total energy generated. And this very simple diagram shows how we generate it on the surface of the painted steel, and then we draw it into the small box. But we've had a bit of a problem with this, because it's a bit too good to be true, and not many people actually do believe it. I'm not going to do the impression, which I've been practicing actually, of Victor Melding, but I'll save that for a different day. So how on earth do you persuade people that this is going to work? Well, you've got to make buildings. So this is the first one up in County Durham. The trade name for the product is a solar wall, and they've applied it as the south-facing wall of this particular building. You can't tell it's there because it just looks like a wall, and that's another problem. People aren't able to see it and connect with what it is. In terms of how it works, the yellow bars show the ambient temperature up in County Durham, and the red and the green line are the gas bills before and after the installation of the solar wall. And that resulted in a 50% reduction in their gas usage. People didn't believe that, so we've got BISRA to monitor it, who are independent, and we've had sustainability consultants look at it as well. And as you can imagine, because the product is so simple, there's some paper sealed holes in it, it's it comes out very, very well when you compare it with other types of renewable technology. I'm not going to take you through all this, there's not enough time, but in terms of the amount of energy saved and the amount that cost and its ability to meet things like the Merton rule, this performs fantastically well. Then we go another building, this time on 2 walls. Because this was a new modern building with decent insulation, heating saving was modeled to be about 66%, so it's even better. This is at the BRE Innovation Park down in Watford. They've got, and this demonstrates that you can put it onto other materials apart from steel. That's on a wooden cedar structure. It's on the M40 on the Beaconsfield motorway services. Somebody might want to actually stop there tonight and get a cup of coffee and have a look. This is a building near where we're based up in North Wales in Chester. But this wasn't working either. You know, no matter how much evidence you give, trying to explain to somebody that the most efficient solar collector you can buy with some steels and holes in it is a difficult thing to do. And then we got a lucky break. Jaguar Land Rover. They were refurbishing an existing building, which used to be a book house, a book warehouse up in Leamington Spa. They analysed in a very detailed fashion every renewable that they could put onto this building. They had a very limited budget, and top of the list out came the Transpired solar collector. So they put one on, and I'm quite happy to talk to people about it. Does a very good job for them, but more importantly, they've got some nice visual displays of what this thing does. And that's probably a bit small for you to read, and I don't have a lot of time. But the pink line is the ambient temperature, and the blue line is the temperature of the air that they pull in for heating through this solar wall. And you can see that during the middle of the day, over a 6 or 7 hour period, they're getting temperature lifts of 15 to 20 degrees C. So it's enough to heat the building. And a snapshot, which is relatively easy to understand. 9 o'clock in the morning, the air outside is 3.6 degrees, and they're drawing in air, which is at 22, again, which is enough to heat the building. We've actually got some data from January as well, when it was really cold, and on the clear days, when the air temperature is -5, they were bringing warm air at about 20 degrees, which is pretty useful. We're also looking at houses. We've got a project, thanks to the TSB, who have funded it. We're looking at applying this technology to social housing, where steel isn't out of place, because the house we're looking at, which you can only improve its appearance, I think, has actually got a steel roof anyway. So that's going ahead now, and that should be ready within the next 6 months. The challenge is, how do you convert energy that's all developed in the middle of the day, when you don't need it, into a house for use when people are actually in it, and how do you make hot water from that? But we think we've cracked that, and we're on there. In terms of future developments, the main thing is all about certifying this and getting people to believe that it works, and then to incorporate it in all of the relevant standards, lists, and modelling packages. We're well on with that. It's costing us a fortune, but we're getting through it. And the one I haven't included is the renewable heat incentive. Forward consultation is out now, and obviously this isn't included, but we're providing a very strong case for it there. And then it's about demonstrating what is a very simple technology across as many different building types as we can. Obviously large sheds, it makes sense. You'll see a picture there in the middle of what was a hideous concrete office block, student accommodation block at Oxford Brookes University, which we've reclad with the solar wall panels, so we can not only do the refurbishment job, but it can generate heat to the rooms and the buildings as well. Those of you that are technologists, a bit like me, I know nothing about buildings, I'm a coatings guy,